Hey guys, NJ here. So today we're having a look at a new Eachine product. This is the Tyro, let me find it, Tyro 79, which is a continuation from the line of Eachine models that came out earlier, or model that came out a little bit earlier on, which was called the Tyro 99, and I've got my one here. Let me just move this box out the way. And this was, I did a build video on this actually. If any of you followed that and built one of these, you'll know about it. If not, I'll make sure to link it so you can check it out if you're interested. And it wasn't actually that bad for the money. It was pretty decent. There's some stuff on it that's not so great, and after a fair bit of use I can point some of those things out, but for the money this got you flying, and this actually flew pretty well. I took this out to my to the LDO meet and took it up and did some freestyling with it, and it was surprisingly good. You can definitely learn everything you need to on one of these, and so for $99 I do think it's a good package. But as I said, there are some things that aren't so great. So there were kind of four main things that were an issue for me with this one, that I would like to see improvements on. In terms of the build, one of the big ones for me that really annoyed me was the fact that the wires on this are plastic insulated, and plastic insulation, it's just awful stuff because the wire is very stiff, it's not very easy to work with, and the worst thing of all, of course, is the fact that plastic wire melts. So especially if you're a beginner to this, and some people are getting into this hobby, this is the first time they will have picked up a soldering iron, and soldering plastic insulated wires is much harder than soldering the more common stuff that we use, which is silicone insulated wires, because silicone is heat resistant. So when you're first learning to solder, you usually end up soldering for longer than you need to. It's very fiddly, and you apply heat to any of these solder joints for more than a few seconds and that plastic insulation will start to melt. If you're gripping it too hard with a pair of pincers or tweezers or whatever you're using whilst you're soldering, it will go soft and leave tweezer marks in it. So unless you're very good at soldering, that's not going to be very much fun for you, and certainly not help you out in that area. So the biggest thing I wanted to see in any future revisions would be to change to silicone insulated wire. My second gripe, although the motors, they're nothing special, but they're decent enough. The performance is decent enough on these 2306, and these are 2150 kV, which I actually think is brilliant for a beginner because they have enough power on the right prop, which I found to be these Avan props by Emax. They're just absolutely married to this quad perfectly. But the lower kV, they just ended up flying so efficiently, so you get a bit more time. Again, really important. Power's not that important. It shouldn't take precedent over time. When you're learning, you want to spend as much time in the air as possible. So nice efficient motor, but the bearings are trash, and the bearings went pretty quickly. I can tell you now, this one, I don't know if I can find one that sounds particularly bad. Yeah, there you go, that one. If you listen to that, rattly, very rattly bearing that's going, and this hasn't crashed. And again, if you're learning, you're going to crash a lot. Without crashing, the bearings are already starting to go in this, so the quality of bearings is poor. It still flies, it's still fine, but as far as I'm concerned, that needs much better bearings in it. Make it more crash resistant, and it will last longer and run smoother, and make tuning easier, of course, because loose rattly bearings create vibration, goes through the flight controller. So they're all things for consideration. The other thing I didn't like was that you had to mount the VTX on top. There wasn't room inside the stack space. So that's not great. It's not actually a problem. If you're running a GoPro mount, I printed one out and put on the top here. You can see the VTX at all angles of a crash is going to be protected. I suppose a bonus of that is you do get exceptionally good cooling, but it's not ideal to have it up there. You really want it inside the cage. So I would like to see that taken care of or addressed. And probably the one that annoyed me the most was the fact that the standard ESC and the VTX on this actually did nothing to address the way of electrical noise. And I had the suspicion that as soon as I started building this, I took one look at the ESC and noticed an enormous lack of capacitors anywhere to be seen on the board itself. I did end up adding a capacitor myself, but really just a capacitor on the plus and minus terminal, it's only one part of what you need to suppress the electrical noise, even on a 4-in-1. If you're running individual ESCs and you put a large capacitor on the back at the plus and minus terminal, and then you measure the amount of video noise you get, versus putting a capacitor, if you divide the capacitance of say 1000 microfarads into 4 times 250 individual microfarad capacitors, low ESRs, and you put those individual capacitors, one on each ESC, you would have you would literally have no noise at all. Like, that would kill any kind of ESC noise, back EMF, motor braking noise that would get through the video. It would all be gone, and you would see a vast improvement of doing them per ESC than just running the sum of that capacitance as one capacitor out the back. So it is important that there is some strategic placement of certain points on the ESC schematic where capacitors should go, and there was no effort for adding any kinds of capacitors to either the ESC or the VTX. There was just no effort made, and thus this was a very noisy quadcopter. So yeah, those are my kind of big things. I mean, there's a lot of nitpicking here. If you're just starting out, a lot of this you won't care about. It will fly, you'll have fun, and $99 isn't an awful lot of money to spend. But as I said, that's not the focus, but all relevant stuff. We are going to have a look at this guy. So this is the Tyro 79, as in $79, and this is the 3-inch variant. They've had a little bit of time with this design now, albeit they've miniaturized it for a 3-inch to hopefully refine some of those issues. One of the things that I always do is I always feed back to Banggood, and I've got into plenty of arguments with their R&D team before over certain products. I did do over a certain set of goggles that they released not that long ago that had horrible latency and a terrible problem with nose fitment, and after a lot of arguing they came back with their tail between their legs and asked for suggestions on how to fix it. So they do listen, not always. Sometimes they're a bit adamant on things staying the way they are, but either way, the point is I did feed back the information I've just told you about the Tyro 99. Anyway, let's have a look at what comes in the box. So we have, there's our frame, and it looks to me like, oh, it's really well sealed. I'm not expecting tremendous things from the carbon, not an especially tight weave. The lamination looks looks all right. You can see there's quite a lot of flex in there. I wouldn't consider that to be a super stiff piece of carbon, but I'm sure it will suffice. But yeah, this is what you get. Obviously, if you start going down in the amount of money spending, things are going to get a little bit lesser quality than what you'd expect from the more premium stuff, but yeah, that, you know, it'll do the job. So we've got the frame, we've got a bunch of hardware here, I imagine motor bolts, we've got standoffs, camera screws, looks like we've got various bits in there. We have a VTX here, and I will put the specs up of the VTX for you to have a look at. I can see a 4th wire here in the loom, which is good, because that would obviously indicate, hopefully, that we have smart audio in there as well, which is a welcome thing, because the other one didn't do that. So that's well, again, I guess it wasn't a problem because the VTX was mounted on the outside of the quad. You just push the button, but you know, the smart audio is just something we're used to. Smart audio or Tramp IRC is something that we expect now, really, on our quads. So it's good to see that is a nice little welcome upgrade. Now, the camera, we have got, see, I don't know if I pointed out all 4 things on the last one, but yeah, that was another thing. I thought the camera was trash, but I did say that in the review video of the Tyro 99. The camera was awful, so let's hope they've made an improvement here and gone for a decent camera. It does look to be a micro form, and I'm guessing a sort of run cammy clone type thing here, but we will have a look at that when we get it all together and working, and see what the quality is like and the light handling, etc. So we've got that. Now let's have a look at this 4-in-1. So we've got a 20 by 20 stack, and straight away I can see the presence of capacitors. You see these little beige things here, and they all look strategically placed. And let's have a little look on the other side. And there seems to be, yeah, there's a row of 4. It's tricky to actually angle this where you can see. There's a row of 4 of them on the top side, and there's more on the top side. So they've actually made efforts to make sure that there is a decent number of capacitors in there. And of course, we've also got a capacitor wired to the back where the XT30 will go. So that's good. That's already promising, I think, to see that. And the flight controller, this is all plug and play. We've got blocks for everything, so there's they try and minimize the amount of soldering. Looks like we've got a boot button here right next to the USB port. Best place for it. Nice and easy to chuck it into DFU mode if we need to. And there looks like there's a few solder points as well, should you require those. I'm not sure if we've got any TX and RX capability. Have we got any breakout points for that? Yes, we have. It looks like we've got access to TX2 and RX2, which is decent. So we have some UART breakout there if you want to make use of that for anything in particular. And oh, that's interesting. Look at that. They've actually included soft mounts. So you've got M2 rubber mounts in there. That is good. Every small build, actually all of my builds have rubber mounts in them. It's just, yeah, it's just one of those things. It helps with vibration. So yeah, that's good. I'm impressed with what I'm seeing there. That's already a significant step up from the last thing we saw. Let's have a look at the motors. And are we going to get... Uh-oh. Yeah, that's plastic insulation again. Well, that is terribly disappointing. I'll tell you why that's disappointing. Because I did have a look at the product page. And the product page, I'll show you a close-up of the picture. You can see written on the side of the wire in the product page shows it is actually silicone. You can see the word silicone and the AWG number of that wire is on the product page, and the actual release here, they've gone back to plastic wire. That's a real shame. Well, that, I think, I mean, I did feedback about this. I'm surprised they've done that again, but ho hum, we've got some improvements, but not all of the improvements we wanted. Can't really say much about these motors because, again, I'll be really looking for, I'm sure the performance will be ample, but it's the bearings that I'm more interested in, but we won't see till we start doing some flights. And it looks like they're 1607 2800 kV, so yeah, I should think that'll probably be alright. 3 or 4S, but we shall experiment with different voltages on that and see what we get. So we got 4 of those, and again, I really kind of think this is an unnecessary thing these days, but some companies just insist on it, which is to have a clockwise and counterclockwise running thread, so that basically as the force of air is applied opposing the direction of the prop, if the prop is to slip, it actually tightens the nut. That's the idea behind counter-threaded lock nuts, but I just think it's a waste of time. The easier thing to do, which you'll see on most good motors, is just to make sure that you properly knurl the base, so when the prop sits on it, it grips, and then they can all be clockwise rotation and it will grip and you won't get any slipping. So I don't feel the need to do this, and it also means you've got to hunt for the specific direction if you want to replace it. But okay, that was their choice. That's what they've decided to go with. Not the end of the world. We've got a battery strap, micro size. We have some zip ties. Looks like we've got the side plates and the little top platey bit, similar to the design of the larger one. So this all looks very similar. We have, these are a throwback. So we got some 3-inch quad blades, and these are the Bullnose. Now, I'll be honest with you guys, this is such an old design of prop, and we've all moved on from this. All Bullnose does is offer, they offer a lot of performance, they offer a lot of power, but they are horrendous on efficiency. They're not efficient at all. They'll cream your battery. So yeah, if you want to go fast everywhere for about a minute and a half, then go with these. Maybe a couple of minutes of flying. They might be alright on gentle flying, but generally speaking, I would always just never go with props like these. I'd always use a decent, like a Dal Cyclone or something similar, which has a nice rake, decent profile, tapered, something that's far more efficient. So they're in there, they'll get you flying, but I can't say I recommend them. So if you're going to ask me for my build spec so far, I did say with the last one, you buying the quad, get a camera with it too, because the included camera is trash. This is now the first item which I will say this is trash. At least it's something cheap, but get another set of props. And I'll link some props that I think would be more suitable to this in the description, but I just don't think these are good. They'll get you going, but they're not the way forward. Let's see what else we got. We got a couple of carbon tools. They're fine. Usually end up losing those. Not a fan of them, but you know, it's a nice little thing. This goes with the battery strap goes through this. It's like a battery protector, so that when you have smacks on the ground, the plate takes the impact and you don't puncture your lipos. Run that if you like. Looks like we've got a couple of foam pads. We've got a rubber pad there, so just standard kind of accessory stuff. Got all our plug and play bits and a pigtail, which is an XT30, so that's what we're designed for, an XT30 battery to go under there, 3 or 4S. That's fine. We have some spare motor nuts. That's nice. Nice thing to include. That's good. We have another bag of small M2s. We'll suss out what they're for when we build it. And finally, I think that's it. Yeah, we've got the side plates, and this is for the wire. Although the antenna. Although I was going to say that's possibly an SMA sized mount. So I imagine it probably is. The VTX that you get comes with a dipole linear antenna, so that will pass through there, but it doesn't really offer much more than acting as a guide to go through there. So that's what you get for your 79 bucks. So I'm not going to do a full 1 hour build guide on this, because the build techniques and how I go about putting things together are all covered in the Tyro 99 video. It's not going to differ from this because it's almost exactly the same, in fact less complicated, because we have a unibody frame. Okay, so this dirty section is now done. We've got our ESC in place, and we have the 4 motors wired in. There's a couple of things that we can quickly talk about before moving to the next section. If I flip this over, the same bolts that go into the motors, which are, you'll see there's plenty of them here. Take a quick look. They look to be about 6mm in length of the actual thread, and they're quite a kind of dull finish, as opposed to these shinier ones which are for the frame. You use 4 of those as well to go into the base of the stack. So we've mounted the stack on there. Obviously each motor has the 3 wires which go to any of the 3 pins in each corner. It doesn't matter which way round they go, because we can program the direction of the motors once we get everything together and in beta flight. So that's pretty much a straightforward and easy thing to do. I've wired on the XT60 pigtail, and I've angled these so that the wires will actually fall kind of either side of the capacitor, so that this, if it does go kind of this way down towards the battery, it's not going to just press against the top of the capacitor. It just kind of makes things a little bit nice and neater. So with the this side is the back of the quadcopter. There is something just to point out here. I remember with the build video I did on the Tyro 99, one of the most asked questions from beginners was really just a lot of confusion about how the direction of either the clockwise or counterclockwise threaded motors should go. Now, on a quadcopter, the way a quadcopter yours is using torque differential, and you have 2 motors that run in the same direction, and then 2 motors diagonally, that is, that run in opposing directions, so they're basically lined across an axis. And you have 2 of them rev up faster and 2 of them slow down, and then when the 2 revving up faster, like this back left and front right, when they rev up, because they're moving in a counterclockwise direction, as they rev up faster, the counter torque will make the quadcopter turn right as these 2 slow down and don't resist the torque of these 2 motors, and then the opposite is true to make it turn the other way. So that's why we have the motors in the direction they do, but it's relevant to the actual top nuts, because what we have here, for instance, this one is threaded kind of the non-correct way. The silver ones are threaded in the way that we're used to, which is, if you don't already know this, the old mechanic saying of righty tighty lefty loosey. As you turn this clockwise it tightens, as you turn it counterclockwise, it loosens. And the whole principle of this, because we have motors running in different directions in sets of 2, is that as the prop slips against the counter to the direction of rotation, so for instance this motor here is going to be turning counterclockwise. So if this motor was to spin very aggressively very fast, the actual the force, the direction on the prop is in the opposite direction. So the prop, if it was to slip, would slip clockwise. Okay, so counterclockwise rotation, the prop would slip counterclockwise. And the idea is, as it's slipping counterclockwise, sorry, as the prop's slipping clockwise, the clockwise, because it's being pressed on by this top nut, the clockwise movement will actually tighten this nut further down. So if the prop does try to slip, it just adds more compression by tightening this. The whole point is that it doesn't, the prop slipping doesn't make an action towards loosening the nut. So with this one, you've got the opposite is true. This is a clockwise spinning motor. So if this motor was over here and this was spinning clockwise, if I held the top nut still, as it goes clockwise, you can see it's actually just pulling the nut off. So I hope that kind of clears things up. It's a little bit difficult to describe exactly what's happening there, but I hope you get the gist of it. And that's why we need, with the back of the quad here, bottom right, which is motor 1 as far as Betaflight's concerned, is going to have the black thread on it. Motor 2 will be silver, motor 3 will be silver, motor 4 will be black. So make sure you arrange the nuts in that order and you'll be fine. In terms of laying it out, it's all pretty straightforward. Make sure to straighten out these plastic wires, these plastic insulation wires. Just try and keep them nice and low profile like that. I've chosen to go round the standoffs and then in and over to the ESC connection points here, so that everything is sort of inside and protected once our flight controller goes on top like that, and it just keeps it all nice and neat. One last thing I'm going to do here is just take my multimeter and I'm going to put it into continuity mode, and what this will do is when I touch the contacts I get a beep. Now the whole point of this is just to check. I just like to do this at this stage before I move on. I just check between the plus and the minus that we have no continuity. The circuit is not being made, which is good. So that means that there hasn't been any problems with how this is wired. The other thing you can do, it doesn't really matter for this quad, but it's certainly good practice whenever you're building a quad anyway, is just checking that nothing is grounding on the carbon and getting back to the flight controller. These type of motors which have an open bottom to them, those it's very easy to see that the screw hasn't gone too far in and is touching the underside of a winding. When you have a completely enclosed motor, sometimes that can happen. What you end up is grounding one of the coils, which can give you undesirable effects in flight and cause your motor to do all kinds of weird things. So the easy way to check that is actually to make a circuit. If you go in on the side of the carbon where it's not it's not lacquered, you can usually make a circuit, you see, because obviously carbon's conductive. And then what I'll do is I'll just touch round each of these ESC points and make sure that I haven't got any noise coming from my multimeter, so I know there's no continuity between any of the screw points and the ESC points, so there's no circuit being made. So I'm happy with the way things are here. We can move on with the next part of the build. Now in terms of installing these side frames, you'll have the side frame mount to the main unibody frame at the bottom there, like so, and then on the outside of that you'll be mounting these carbon plates. Now just doing a little dry fit here, you can see that when this goes together, those carbon plates are going to be quite close to those motor wires. And this being a cheap quad, the quality of the carbon is not fantastic in terms of how it's finished from being cut. So what I highly recommend you do is these edges on both sides are going to come into contact more than likely with the motor wires while the quad's vibrating. You really want to make sure none of these edges are sharp. So you're going to take really something like this, a tiny fine needle file, and then just file the edges at a 45-degree angle, just a few strokes to get rid of that and make sure it feels nice and smooth to the touch. Please make sure when you're filing carbon you're doing it over, do it in a bowl of water. Keep the file wet. We want to make sure the water collects the dust particles from carbon. You don't want that going in your lungs. So yeah, just file 45 degrees, a few strokes on either side like so, and then we know if the motor wires brush past that, there's no chance of any soaring action going on and causing us problems later down the line. The easiest way to move forward with this now is to basically install this side frame with the plate on it. So you can use 3 of these side frame screws, which are the shiny ones, as I mentioned here, just in those 3 positions. So we're going to arrange 2 like that. As I said, the carbon plate is towards the outside. And then on one of those I've assembled, to make it look like it's kind of a cross section, I've installed the camera. Now the camera screw is the little tiny screw that has the Phillips head on it, so that will go into the side of the camera. In terms of the wire connections here, it's pretty easy to do. There's only one real thing that you have to be aware of. So the camera connecting block, you will see, has the positive towards, the way to identify it, it has the positive towards the far left side of the connector. So when you see that red wire, you know that's the correct block that goes into the camera, and then the other one will go into the front of the stack. It's a little tricky to see here now. There's 2 plugs at the front of the stack. One is the other side of the camera connector, and the other one is the big 6-pin connector, which comes from the ESC underneath. So the 6-pin connector goes from the ESC to the front of the stack. Next to that is the camera connector, and we've discussed how to identify which side goes into the camera itself. They're different connectors, they're different types of JST, so you can't really get them the wrong way round. The VTX, which sits on top, it does actually kind of install upside down, and the UFL pigtail connector, which you can just see there, goes on the underside of the board. And the reason for this is that the VTX itself, can you see these tool components? So these tool components won't actually, they don't have the room. If the VTX is flipped the other way up, those tool components will make contact with things like the USB plug and some of these connecting blocks. So you have to flip the VTX upside down with the UFL connector on the underside. Not really ideal. I prefer to have the UFL on the top side because it's easier to disconnect and reconnect the aerial if you need to work on the quad, but you know, it's not perfect. And the VTX itself, you can see the actual wire loom for that comes in the VTX package, and it's got the green wire on it. As I told you, this has smart audio, and that connects to the side of the F4 flight controller. It's this block on the side, so that goes to our VTX at the top. And then at the back here we've got this wire here. This will be going to your receiver, so you just the easiest way will be to cut this and to solder directly to your S-Bus receiver. If you're running FR Sky and running S-Bus, I'd strongly recommend using something like an XM Plus. That's what I will be putting into this. And then probably sitting it either on top of the VTX or maybe some room back here. Make sure you heat shrink your receiver, because if you're going to put it anywhere near the VTX does get quite warm. So you don't want that causing any problems for other components inside there. But there isn't a lot of other options because it's quite a tight amount of room in here. But maybe you could use these holes in the top plate to run a zip tie and have your receiver on the underside of this plate. That's probably the best thing to do, and that will leave you a little bit of an air gap between that VTX and your receiver. So you assemble it in this fashion. The only other thing to note here as well is the long screw. I think this is an 8mm thread screw. There's only, I think there's 3 of them. 2 you need, 1 is a spare. That is the one that you will use to connect this, because it actually passes, it's the only screw that's not threaded to the actual frame. It passes straight through like that, and then you have, 3mm of thread exposed, which is then going to be used to connect this antenna guide. Other than that, and the note about the screw for the camera, you just use the other shiny bolts to connect all these little parts and the frame, the side plate to the frame, and then the standard dull kind of motor bolts. Those are the same types that you use to connect the frame to the base, to the unibody carbon plate. So that gives you a little idea of what that looks like. The rest of it is pretty straightforward from here. Once that's all done and nice and neat, we're going to put on our other side plate. And finally, at this point, we're pretty much ready to go. I still have to install my receiver and bring the antennas out. I'm still kind of deciding where I want to bring the antennas out. They haven't really put much thought into where to run the antennas out the top. Usually in frame designs, I like to see things like these little cutouts here. It's nice to see some spaces in areas towards the back where you can run some zip ties to actually have the antennas come up and out. But what I may end up doing is utilizing perhaps this at the back, have a couple of zip ties here so that I can run the antennas up and out at 45 degrees to each other for diversity reception. So that's what I will probably do. As I said before, I really recommend just not bothering with these. Put some nice props on there instead. These I will link in the description. These are my favorite 3-inch prop made by Dow Prop. So I'm going to be running with these because I know the performance of these and how good they are and how efficient they are. In terms of final kind of notes on this, please remember, again, if this is all new to you, that you have, once, as well as deciding the direction of the prop nuts to go on, which we did earlier, it's very important that the props are going the right way. As I said, there is a specific direction for everything to run, something we have to configure in Betaflight, which we'll do in the next video. But the main thing is to remember that the direction of the props always move in towards the body at the front side and at the back side. So that's a kind of a nice easy way to remember. The props go inwards towards the nose and then they go inwards towards the tail. So make sure you put your props on in the correct direction. The high part of the blade at the front and the trailing edge has the lower part at the back, and that determines the direction of the prop, and you always go in towards the nose. So that's how we determine the direction of the front, and then, as I said, at the back we're going inwards towards the back. So once you've got your props on, you've installed your receiver, and we've got everything together, it should look something like this. And I've got to say, it's a pretty tidy little package. Now let's get ourselves a weight just to see where this comes in at this state. But as I said, the only kind of extra things we need to do, we've got a weight of 152 to that point, so really very, very good in terms of weight. The only other bits really that we'll be looking to add to that now are an XM Plus, so there'll be a few grams for that, which will be the XM Plus. You can look at the specs of that, they don't really weigh anything. We're going to be adding a battery strap, and then in terms of both 3 and 4S, I've got a 3S. I'll be testing it on one of these, which is this Ready Eddy 550 milliamp 55C 3S. Love my Ready Eddy batteries, they're fantastic. So I'm going to be chucking that on there, and that will give us a weight of 211. So even with a few grams of an XM Plus, you can see we are well under that weight of 250 grams, which matters to us here in the UK, well, and in Europe, which is nice to know. And then if we take one of these AC 650 4S 75C packs, so this will be the real performance pack, and these are good. I've tried these on a bunch of different small quads. If we put that on there, we have a weight of 240 grams. So yeah, there's absolutely no doubt we're going to be under that 250 gram mark, which is fantastic. That's really good news. So in terms of wrapping this up, what can I say about this quad? Well, there's definitely been some improvements, some more attention to detail. And I think compared to its bigger brother, the Tyro 99, we should have a much nicer experience. As I said, there were a few things I was a little disappointed about along the way. The big one for me was that the fact they're still using the plastic insulation on the motor wire. I think, especially if their target audience is to try and help beginners get into this. Not that this isn't going to be a great 3-inch quad anyway for anyone that wants to buy one at a good price point. I think this is a good little package with a decently spec'd components. But you know, it's just a few of those things. They were pointed out to Eachine on the last model, and it's a shame they didn't do it. There are some other things that we need to test, and that will come in the later video. For instance, the quality of the camera and the settings in that. Make sure that it's all good. Hopefully, it's well set up out the box, and we have a decent picture. So I'm hopeful for that. And the other thing I won't know until I've done a few flights on this is the longevity of the bearings, because again, on the old model, the bearings went very fast. As I said, without a crash, it just had problems. But I think you'll agree it's a very tidy and quite cute looking little model. So I think at that weight on 4S, this should be a little screamer. So yeah, on the whole, this does get a thumbs up from me. As I said, please put an asterisk next to that, because there are certain things that need to be tested once we get flying. But in terms of my first impressions, how easy this is to build and the nice little improvements they've added, like those rubber standoffs and various bits, it's good. So I hope you enjoyed that video, guys. Please leave your comments and questions in the usual place. I'm always active to come in and chat to you guys. And I will see you all in the next one, when we will be having a look at this flying. Take care for now.